Alright, so the shadowdom tree that we looked at in the previous video is a hidden tree that's not reflected in the HTML. The opposite of the shadowdom tree is a light DOM tree. And yes, I'm not making this up. There's actually a thing called the light DOM tree. In fact, anything that's not part of the shadowdom will be considered as light DOM. So the first video where we use the custom elements API to create our element, everything in that video was light DOM. It only changed once we introduced the shadowdom in the second video. So if I create a button right below the progress bar element, this button is part of the light DOM tree. I can attach any style to this button in the global scope and it will render with those styles. So if I go back to the browser, you'll be able to see this button right here. Now if I move this button element inside our custom element, it will not be displayed. You can see that the button is not there anymore. If a custom element has shadow DOM in it, it's not going to render any light DOM elements. That is the main reason why slots were introduced in the first place. But this is where it starts to get interesting. The button here is not the only element that's part of the light DOM. The span slot that we have is also considered as light DOM. Anything that's inside the shadow DOM host element, even slots, is part of the light DOM. So the global styles that we have in our CSS file will update the styles for these slotted elements. If I change the background color for the span inside the global style sheet, it will actually change its color. Yeah, you can see that the span element now has a background color of pink. So basically inside the shadow DOM, a slot with a name attribute defines an insertion point. This insertion point is a place where elements with a corresponding slot name inside light DOM will be rendered. The browser actually performs composition, which is basically taking elements from the light DOM and rendering them inside corresponding slots of the shadow DOM. At the end, we have exactly what we want, which is basically a component that can be filled with data. If we take a look at the elements section inside the browser, you'll see that the host element first has the shadow root, and at the end it has all the slot elements. Now if there are multiple elements in the light DOM with the same slot name, they are going to be appended inside the slot one after the other. I'll just get rid of the button for now, and I'll copy the slot. I'll change the values for all these slots. Now if I go back inside the browser, you can see that we have 3 slot values and each of them is appended in the same slot one after the other. Now in the previous video, we had looked at the fallback default content inside a slot. So if I pass in some value inside a slot and inside the light DOM there is no element with that slot name, then it's going to render this default text that we have inside the slot. There's also a concept of a default slot. So the first slot without any name is a default slot. This default slot gets all the elements from the light DOM that are not slotted anywhere else. For instance, let me actually create a default slot at the bottom right here. So I'll create a slot element without any name. And now any elements inside the light DOM that do not have a slot attribute will be rendered inside this slot. So let me actually create a few elements. Now if we go back inside the browser, there are these 3 elements that we have inside our light DOM, and all these 3 elements do not have any slot attributes. So they automatically get rendered inside the default slot that is placed right at the end of our progress bar. Now all these slots also have a change event just like any other HTML element. The event is called Slotchange and you can use it to detect if a slot has changed in your DOM tree. The problem with this event is that it does not track the contents of the slot. So if the inner HTML or the text content inside the slot changes, which is probably the most common use case, the slot change event will not be triggered. For that, we'll need to use something like a mutation observer, which is what we'll look at in one of the future videos. Now, when it comes to styling your component, you'll need to keep a few things in mind. As I mentioned at the beginning of this video, the elements inside a slot are part of the light DOM. So these elements will take the styles from the global style sheet and will have no effect from the style tag that we have inside a template. That is one caveat that you'll need to remember. If you want to style the host element, which is basically this progress bar element right here, we can use the host selector inside your template. But keep in mind that the host itself is part of the light DOM. So this progress bar element is part of the light DOM tree. So you'll be able to actually style this progress bar element inside the global style sheet as well. We'll look at both of these examples and see which one takes precedence over the other. So let me actually create a host element inside the style block. And I'll set the background color to yellow. If I go back to the browser, you'll see that it actually works. The background color is being attached to the host element. Now inside the global style sheet, let me attach a background color. And now if I go back to the browser, you'll see that the gray color takes precedence over the yellow color. So basically the styles that you have inside your global style sheet take precedence over the host selector that is part of your template. One more peculiar behavior is that the CSS variables that you create globally can actually be used inside your shadow DOM. The reason is apparently custom CSS properties like CSS variables pierce through shadow DOM, which makes them visible basically everywhere. Inside the global style sheet, I'll actually create a variable for the background color and I will set it to gray. I can get rid of this, and inside our HTML file, instead of yellow, I'll use the same CSS variable. Now if I go back to the browser, you'll see that the background is still gray in color, which means that the background variable that we are referring to, which is coming from this global style sheet, actually works. So this basically means that the CSS properties that are created inside the global scope can actually be accessed inside the shadow DOM. Now let's quickly add this web component inside a React application. It's actually pretty straightforward. I have this basic React application created using create React app. Inside the source folder, I'll copy our web component. Now to do that, I'll first need to make some changes inside our current web component implementation. So the script file needs to have everything, right from the HTML and styles to the JavaScript logic. So I'll actually copy everything that's inside our template, and I don't need this anymore. I can just create a template element, and the inner HTML for this template will be the content that we just copied from the HTML. This background might not work because we are fetching it from the global style sheet, so I'll just set it back to yellow. And yeah, now I can move this entire web component inside our React application. Now inside the app file, I'll just clean up everything from here. And I'll just use the same progress bar tag that we had inside our HTML file from the web components project. So I'll just copy this. And inside the React project, I'll just paste it. I won't need these elements anymore, so I'll get rid of them. Now if I run this by using npm start, you won't see anything because you'll need to actually fetch the contents from the script file. So let me just import the script file first. And now if we go back to the browser, you'll see our custom element. If I try to increase the progress, it works. If I try to change the color, it also works. Now what if I want to make this dynamic? So what I mean by dynamic is I want to pass these attributes from this React application. So one way of achieving this would be to create a wrapper for this component. So let's do that. I'll create a progress bar component. So new file, progress bar.jsx. This will be a functional component. And I'll just copy the progress bar inside this component. The import statement as well. Now the values for these attributes will be coming from the props. So I'll just set all the values here. At the end, I'll need to render this progress bar element inside the app file. So I'll get rid of this. I'll have the progress bar. And inside this progress bar, I'll pass in the same set of attributes. Now if I go back to the browser, you'll be able to see the progress bar with all its values and all its functionalities working as expected. I can also set default values to these props. So while declaring, if any prop is not provided, it will fall back to the default values. So let me do that quickly. Inside the wrapper here, I'll get rid of all the attributes. Now if I go back, you'll see that there are default values set for our progress bar element, and it will still work as expected. And yeah, that's pretty much it for this video. There's plenty more that you can get out of web components. This is just the start. There are a bunch of libraries that help you building web components. Maybe in the future, I'll create a separate series covering the popular ones. Apart from that, if you have any doubts or suggestions, you can leave them in the comments. And yeah, I'll see you in the next one.